In this video, I'd like to talk about the graph of the sine function. Or in other words, we want to take a look at the picture for y is equal to the sine of our angle, which we can call theta. And on this coordinate axis, this would be the theta axis, and this would be the y-axis. And to construct this graph, what we will see is that we'll end up with a function that looks like a wave. But to actually create this, we will need the unit circle and we'll need to construct a table so that we can actually plot points. So anytime you want to create a graph of a function, remember that you can just create a table and plug in different values and then plot those points. So let's make a little bit of room, and we just need the unit circle. So let me paste in a picture of that. And remember with the unit circle, that the distance from the origin to any point on the circle would be 1. And we measure this angle. This is called theta. And we measure positively going in the counterclockwise direction and negatively in the clockwise direction. And the coordinate point x comma y on this circle, at any point on the circle, the x value is the cosine of the angle, and the y value is the sine of the angle. And since we're graphing the sine function, we are particularly concerned with the y value at any point on this circle. Now, I mentioned we also need to construct a table, so let me do that very quickly, where we want to look at the theta value and the function value, which is y, or the sine of that angle. And for theta, we can either do this in degrees or radians, but for this, we can do that in both to compare the two solutions. But the actual scale of the graph, we will do that in radians, though if you prefer, you can construct this using degrees as well. And to start, we can look at when theta is equal to different key values. We can look at when theta is equal to 0 radians, when it's pi over 2 radians, or 90 degrees, when it's equal to pi radians, or 180 degrees, when it's at 3 pi over 2, or 270, and when it's at 2 pi radians, which is 360. Though we can also look at the negative values. We can look at minus pi over 2, which would be minus 90 degrees, minus pi minus 3 pi over 2, and negative 2 pi. And I'll fill in these very quickly. And once we fill in these main values, we can then look at values in between them just to see what's happening. But these key values will give us a general idea of what's going on, and the fact that this function and the cosine as well, these are periodic. They will go back and forth between particular values, and that has to do with the fact that this angle theta essentially repeats itself every 360 degrees, or 2 pi radians. And of course, we can go in the negative direction, 360 degrees, or subtract 2 pi radians, and that way we'll get back to the exact same point, which would have that exact same y value. Now, starting with an angle of 0 degrees, or 0 radians, that would be at this point right here on the unit circle. And the y value of this point, the sine value of this point, would just be 0. It has no height to it. But when we go to 90 degrees, or pi over 2 radians, we will now be at this point up here, which is where the x value is 0, but now the y value is 1. Since remember, the distance from the origin to any point on the circle is 1, and it's all y values here. So the sine of pi over 2 radians is 1. But when we go to 180 degrees, or pi radians, we end up at this point, and again, it has no height. So here, the y value is 0. But when we go down to 3 pi over 2 radians, or 270 degrees, the y value is now negative. Notice that this is a y value of -1. So the sine of 3 pi over 2 radians is -1. And when we go 2 pi radians around, we end up back at this starting point here, or 360 degrees around. And this is the same value when we plugged in an angle of 0. So at 2 pi, or at the sine of 360, the y value, or the sine value, is back to 0. And for the negatives, we just go in the opposite direction. We start at 0, then we go to negative pi over 2, which is down here. We know the y value there is -1. When we plug in theta is negative pi, that brings us to this point here, which is the same value for when theta was pi, meaning that the y value there is just 0. It has no height to it. When we do -3 pi over 2 radians, or minus 270 degrees, that brings us to right here. And at this point, the y value is 1. And then -2 pi, or minus 360, brings us all the way back around, where we are now again back at this point, and the y value there is 0. And from here, we can plot all these points. So let me quickly draw all of these in, and we will use a scale of pi over 2. This will be pi, 3 pi over 2, and 2 pi. So that makes this minus pi over 2, and so on. And for our vertical scale, we will use this as 1, and this will be at -1. So let me plot these points very quickly. And once these points are plotted, we can see that this function does go up and down in what looks to be some type of wave, but the question is, how curvy is it? Do we just go in straight lines to these points, or does it bend as we go through these? And to answer that question, we need to plot some points in the middle of these points.